Hi geometry students, and welcome to the chapter 3 test review. So this video will go problem by problem through the chapter 3 test that is in your book. So it comes after all of the review for chapter 3, and it's a one-page test and then has a standardized test next to it. And so if you have not completed that test, I would suggest that you complete it first just to see where you are on the learning piece and how well you are doing. And then just scroll through the video, and I will post this as a PowerPoint as well so that you can actually just go through. If you don't want my voice behind it, that's totally fine. But this hopefully will prepare you for the Chapter 3 test, which is Tuesday. It is already posted on Sycamore, but it is still locked, so I will have it open after midnight on Monday. I will have it opened up, and you can then go on and print it out. Just a couple of instructions. You put your name on each page, and then you need to staple it together. I get so many tests that are not connected, and I end up losing a page or having to go searching through a bag. So please make sure you staple it together. You may use your index cards, of course your theorems, postulates, and all of that. Those are always standard to be able to be used on the test. This is closed book, so depend on the index cards. Okay, so let's start with the first problem. So it's actually the first 5 problems. When I did a screenshot of this, I pulled in question 6, and it's actually on the next slide. So exercises 1 to 5, it says think of each segment in the diagram below as part of a line. Now that would mean that the line would keep going. So if you can't see this just in your mind, then feel free to take a picture of this and or draw it onto a sheet of paper and extend the lines. That sometimes helps then to be able to see if a line is skew or perpendicular more than parallel. So the first one we want to look at is PT and UV. So here's PT. Here's UV. Now if we kept PT going, it would shoot out like this, and if we kept UV going, it would shoot straight up like this. So if you did draw those out, you would see that they would be perpendicular. Number 2, TW, which is right here, a line, vertical line, and WV. You can see this one going here. Those would be skew. We don't have enough information to know that if they could be perpendicular, but they are skew. Now we look at PT and SW. This one should be pretty easy. It's parallel. PQR, so we've got this little kind of plane. And TUV, if you place those one on top of the other, it would show that they are parallel. And it is, so you've got TU, you've got PQ, those are parallel. UV, QR are parallel. So you almost have to look at it as individual segments to figure that out. Then TW, which is right here, and SWV. So TW with SW is showing to be perpendicular. Now we're looking at the plane, not what we looked at a minute ago. So we have a plane. And so again, draw those out. If you're not sure what you're looking at, draw them out. And I think that will help you. Okay, now we look at number 6, which was on the previous slide. We want to know what you can conclude about FGJ. Here's FGJ and JGH, given that FG is perpendicular to GH. Now, I am not necessarily looking for just one thing. I want you to put down everything that comes to your mind that could possibly, any conclusions that could be drawn about these two angles here. So I go back a little further and I conclude that FGH, which they don't ask about, is a right angle because of this. FG is perpendicular to GH. So I go ahead and make that statement. FGH is a right angle. And that's just from the information given if I were doing a proof and I needed a reason. Then FGH equals 90 degrees. That would be definition of a right angle. FGJ plus GGH would combine to equal 90 degrees. And that's just because of basically information we've been given up here. We know that this is a right angle. We know it equals 90 degrees. I've already said that. So putting these two together is the next logical two angles that are next to each other. Can't think of the word right now. In a right angle would equal 90 degrees. Then FGJ and GGH are complementary. That's the definition of 90 degrees. We don't know, though, if GJ is a bisector. So we can't guess at the measurements of the angles. So don't go on to say that each of them is 45, because we can't do that, because they have not told us that if this is a bisector. So put down anything that you know. Show me what you know from these diagrams. And I believe there's a proof that you're going to do in the test where it's already done for you and you have to provide the reasoning. All right, here's number 7. Find the value of x given that C is perpendicular to D. Well, we know that C is perpendicular to D because they tell us. And we also know that that's going to give us a series of 4 right angles. And so that's going to be 90. That one's going to be 90. The C, whatever that is going to be 90. And the 2x plus 14 is going to equal 90 as well. So now we want to find the value of x. Don't tell me what the measurement is. That's not what they ask for. 2x plus 14 equals 90 is what we want to work out. When we solve it, we're going to move that 14 over, subtract it from both sides. So we'll have 2x equals 76, or x equals 38. Okay, the next one, what they want to find out is if you know about ulterior, interior, alternate interior, corresponding alternate exterior, same side. They want you to know that. So what I suggest is that you pull out your index card if you have questions on the test like this. So the first one they ask is about angle 1 and angle 2. Well, they're alternate something and they're on the interior, so they're alternate interior. Now we look at angle 1 and angle 6. Up here's angle 1, here's angle 6. Well, they're corresponding. And so that's what we would call them, as corresponding angles. We don't have to know what they equal here, but they are corresponding. Now number 10 is 2 and 3. They are also corresponding. They're in the same position. Number, what did I leave off? 11. Angle 1 and angle 5. Well, they're alternate something, because one's on this side, one's on that. But exterior. So this is on the outside of this whole piece here. This one's on the outside of this piece here. Number 12 is angle 4 and angle 2, and they are same side. So they're on the same side. And then angle 5 and angle 3 are going to be corresponding. So study that card. Make sure that you're familiar with it. Also use it if any questions come up on the test. Sometimes it can be a little confusing, especially if measurements are thrown in there. All right, the measure of angle 1, okay, up here, is 108 degrees. We find that out from the diagram. Now remember, I've told you that you can find given material in the text or on the diagram. Now they want you to find the measure of angle 1, the measure of angle 2, and the measure of angle 3. And so those sit just with those numbers, and then they want you to explain your reasoning. So the measure of angle 1 is 108 degrees because they are corresponding angles. And so we use the corresponding angles postulate. So that was easy enough to find, and these are parallel. So they've told us enough information right here, and with this symbol right here, showing us that they're parallel. So the measure of angle 1 is 108. Well, that's going to help us to solve a lot of other things. The angle 2 is going to be 72. Now, you can do a couple of different things. You could actually flip this up on its end and call it a linear pair. Or you can use same side interior angles theorem. So go back and review these. So if you had put either one, same side interior angles theorem, or you flipped it up on its side and did linear pair, either one of those would be fine. Next, the measure of angle 3. That one's definitely linear pair. We know this is 108. This is 72. And so we could use either one, linear pair, or alternate interior angles. So you could use 2 and 3. So again, review your index cards so that you know when these lines are parallel, what these interior and alternate interior angles, what information that gives you. Okay, let's move on to the next one. In exercises 15 and 16, find the value of y so that m is parallel to n. I don't like the language here. This is actually just given information. M is parallel to n. So we know that in both cases. Okay, what we're going to do here is, and I actually think I only solved one of these. I only solved 15, so I'll have to give you the answer for 16. But in this case, these are both parallel. So what we can do is we can actually use vertical angles or alternate exterior angles. So if we did vertical, it would mean that 3y plus 1 would be the measure of this as well. So 3y plus 1 equals 67. We subtract the 1 from both sides. We get 3y equals 66. That means that y equals 22. Now, I didn't give you the answer for the next one. So let me quickly go to that page so that I can give you that answer. And if you need me to work it out, I am happy to do that. So let me get there. I'm almost there. And the answer for 16 is 32. So see if you can work that one out and figure out how you come to 32. I will fix it on the PowerPoint before I post it. So if you're having trouble with that, then go back. You're looking for interior angles, and so go back and make a determination there. Okay. The next one is 17. The carpenter wants to cut 2 boards. It shows you the 2 boards here to fit snugly together. I'm assuming he wants to cut these corners off. The carpenter's squares are aligned using EF as shown. Are AB and CD parallel? State the theorem that justifies your answer. So they want to know if AB and CD are parallel. And so you would have to answer that. We find out that this line is perpendicular because they show us this is a right angle. This line is perpendicular because it shows us a right angle. And if 2 lines are perpendicular to the same line, they are parallel to each other. And then finally, the translations or the slides, whatever you want to call this. The blue figure, you're going to move from the blue figure to the red figure. And so you have to tell me how it's moving. So the blue figure is going to move 1, 2, 3, 4, 5, 6. This is where the new corner will be. And then up 2, and I'm going to put that point, this point right here is going to land there. And then I would do that same thing, 4, 5, 6, up 2, and I would have my new translation. And so you would write that out in words. That's what they ask you to do. And the coordinate notation is something like this: x plus 6, and it should be and y plus 2. So x plus 6 and y plus 2 is going to tell you how you're going to move that translation. Okay, so that gives us the chapter test, and hopefully that's been helpful. Like I said, in the PowerPoint, I will fix the question that I missed, and I will post it with that question added in. If you have questions about any of these and how you get to the answers that we got to, then please email me. And if you email me anytime on Monday, it will probably be sometime in the afternoon or evening that I can get back with you, because I am at school all day on Monday. So just let me know if you have any questions, and like I said, the test will be posted later tonight.